In times of viral disinformation and instant certainties, few expressions are used with such authority as scientific evidence. This phrase is invoked in political debates, public health campaigns, and commercial announcements, as if it were a seal of absolute truth. But what does this concept really mean, which seems so obvious, and at the same time so elusive? Before continuing, I invite you to subscribe to our channel and give like to this video. Your support is fundamental to continue creating valuable content on topical and scientific topics. At first glance, we could say that scientific evidence is that which proves something based on science. However, when we examine it, we discover that it is not a stable object, but a complex process, full of nuances and uncertainties. The evidence is constructed, questioned, and sometimes contradicted. Understanding the nature of scientific evidence is fundamental to engaging in debates on diverse topics, such as vaccines, artificial intelligence, climate change, or nutrition. Science is not an exclusive territory of professionals. It is a method accessible to all. The validity of a result does not depend on who produces it, but on how data are generated and evaluated. However, modern science has become so technical that some experiments require equipment and expertise, creating practical barriers. One of the most important ideas is that not all evidence weighs the same. The evidence accumulates and is evaluated as a gradient. The classical hierarchy of scientific evidence is useful, but in real life, the best available evidence depends on the context and feasibility of the studies. For example, it would not be ethical to randomize people to smoke or not to smoke to study lung cancer. Therefore, well-designed observational studies become the most robust form of evidence possible for these problems. Reproducibility is key to validating the results. Contradictions between studies can be disconcerting, but they are an essential part of scientific progress. Different groups can study different populations and use varied methods, which can lead to contradictory results. The key is in the quality of the study. Although we often talk about the scientific method as if it were a unique recipe, reality is more diverse. Different disciplines use different methodological approaches, adapted to their study objects, but all share the importance of transparency in their processes. The most fascinating feature of scientific evidence is its provisional character. A scientific statement is strong because it is subject to review. This flexibility is one of the pillars of modern science and helps to accept uncertainty as part of the process. Scientific evidence is not a final verdict, but a continuous and perfectible process. In a world saturated with data and opinions, understanding its dynamic nature is essential. Scientific evidence opens debates and is a permanent invitation to keep asking,